Welcome to Video Lecture 2.2, Cloud Albedo Forcing and Cloud Greenhouse Forcing. We're going to look at the role of clouds in two different ways. And so the role of clouds as far as preventing insolation from reaching the surface, but also the role of clouds as far as trapping or delaying that long wave radiations being re-radiated back out from surface to the atmosphere here in the troposphere. We're going to focus in on the role of clouds. And so on a normal day, 75% of that incoming solar radiation would actually reach the surface. However, you put clouds into the mix, you put clouds in the way between the sun and the surface, and now only 15% will actually get as the remaining gets reflected back out or scattered in all different directions. Of course, we have a name for this increase in reflectivity due to the presence of clouds, and that term is cloud albedo forcing. And so the key idea here with cloud albedo forcing is because the clouds are preventing that incoming solar radiation from reaching the surface, we should expect cooling at the surface. And so key to understanding cloud albedo forcing is it promotes cooling. But like I've said, we've got two sides of the coin. And so the role of clouds as far as preventing incoming solar radiation, but of course clouds can also do a good job of holding in or blocking or delaying the transfer of that long wave thermal energy from the surface through the atmosphere. And so in many respects, clouds, they serve two roles. As a blocker, but also as a blanket to trap in. Very much like our own body. Why do we use a blanket on a cold evening? Well, because it traps in our body heat. And so our body's re-radiating out heat, just like our Earth's surface is. And so the surface is radiating back out through the atmosphere heat. The role of clouds is acting like a blanket for preventing that heat from quickly leaving and escaping our bodies. And the name for this is called cloud greenhouse forcing. And the idea here is we have an increase in warming we should expect on the surface created by what we call the greenhouse effect, which I define on the following slide. So cloud greenhouse forcing increases or promotes warming at the surface, where cloud albedo forcing promotes cooling at the surface. So the definition of a greenhouse effect that we're going to work with is the idea that the atmosphere absorbs and delays the transfer of thermal energy or heat from Earth to space. And so the idea here is it delays. It doesn't trap, but purely delays or slows that transfer from Earth's surface to space. A real greenhouse will actually trap in that heat inside. We can think about greenhouse gases. We've talked about this in Video Lecture 1, but water vapor or clouds is an example of greenhouse effect as we have focused in on this video lecture series, but also the role of pollution, smog. You could say natural pollution in terms of volcanic ash does a good job of also trapping in heat, but we could also say CO2, carbon dioxide, and so cities. We often find the greenhouse effect in city or in urban areas where there's higher quantity of CO2 in the atmosphere. Here we have an image from a greenhouse, and this is from Indiana in the wintertime. And so you can still grow things in Indiana in the wintertime if you have a greenhouse because it does a good job of allowing that incoming solar radiation to come in, but it also does a good job of trapping in that heat. And so actually it can be, 40 degrees, 50 degrees inside this greenhouse, even though it might be 18 below zero here in Indiana in the wintertime. And so one of the things the real greenhouse actually traps in actuality, the greenhouse, as far as imagining this in reality, in the physical environment, it's more of a delayer, not a trapper. Of course, we can all relate to this. The summer of 2012 will always be remembered as that super hot summer. And even though it was 105 degrees outside, it was even warmer inside our car because our cars very much act like a greenhouse in terms of trapping in that incoming solar radiation that penetrates our windows but is not re-radiating back out through our windows, back out through our metal and steel cars.